A long wire is formed into 7/10 of a circle that has a 3-meter radius. The wire carries a current of 2 amps. Use the Biot-Savart method to determine the magnetic field at the center of the circular shape. Okay, so whenever we're given a problem that asks to find the magnetic field at the center of a circular shape, you want to begin by drawing the circle. So let's say this is a circle. The long wire is formed into 7/10 of the circle, so we want to draw the wire. Okay, let's say this is about 7/10. You don't have to be exact. So if this is the center of the circle, it says here that the wire has a 3-meter radius. So over here is radius. R is equal to 3. And it says here that the wire carries a current of 2A. So the current that flows through the wire is going to be equal to 2. Okay? 3 meters, 2 amps. Next up, we want to recall the formula to find the magnetic field using the Biot-Savart method. So the magnetic field is going to be equal mu naught. Mu naught is just a constant. It's the permeability of free space, okay? Mu naught times the current over 4 pi r squared. All that multiplied by the length element, ds. So let me write this here. So mu naught is going to be equal permeability of free space, which in case you want to know, you don't need to remember this to solve this problem, but in case you want to know, mu naught has the value of 4 pi times 10 to the negative 7 Tesla meters over area, okay? You don't need to know this, but in case you want to know. I stands for current. You know pi is 3.14. R will stand for radius. And ds is the length element. So it would be the length element of this wire. Now, looking at the problem, let's see what information it gives us. Okay, so we know that I is 2, because current of 2A. We know that R is 3, and ds we don't know. So ds we're trying to find. So let's find ds. So given that we have this 7/10 of a circle, in order to find the length element, you're going to have to divide the 7/10 by its circumference. And we know from geometry that the circumference of a circle is 2 pi r. So with this, we will be able to find ds. So let's plug this into a calculator. 7/10 times 2 pi r. R we know is 3, so 2 pi 3 is equal to 21/5 pi. So ds is equal to 21/5 pi. Now that we have this circle, because it's important, we can remove this question mark and write 21/5 pi, okay? Now that we have that, solving this for magnetic field is going to be a piece of cake. So we just plug in the known values. B is equal to mu naught is a constant times I, which I is 2, over 4 pi r is 3 squared, multiplied by the ds. We don't need to find the integral of ds because we already found the value of ds. An integral is just area under the curve. So since we have already this, we're good, okay? So we just have to find 21 over 5 pi. Okay, this multiplied by this. We see pi right here and we see pi right here, okay? Top and bottom, it cancels out. All right, so now we only have to calculate for m naught mu naught times 2 times 21 over 4 times 3 squared times 5. So let's plug that into a calculator. So we have mu naught, which we don't have to write mu naught because it's a constant, so we could set it aside for now. So we have 2 multiplied by, let's do this, 2 times 21, okay, multiplied straight across, okay, over 4 times 3 squared times 5. You get 7 over 30. So the magnetic field is going to be 7 over 30, which translates to 0.233. So B is equal to 7 over 30 or 0.233. And when you write the magnetic field, let's stick with the decimal, okay? So B, magnetic field, is going to be equal to 0.23. Yeah, let's stick with 2 decimals, 0.23. Remember that you set the mu naught aside, so you need to include the mu naught in here, okay? And this is your magnetic field. Units will be in Tesla. And here is your answer.